Hello everyone. Today we are going to solve a geometry problem using the midline theorem. Consider a triangle ABC. M is the midpoint of AB, N is the midpoint of AC. Then the midline theorem tells us that MN, which is the midline, is parallel to BC, and also the midline is 1/2 of the base. We are going to use the theorem to solve a problem. So look at the figure. AB is parallel to CD, and AB equals A, and CD equals B. M is the midpoint of AD, and N is the midpoint of BC. Then what is the length of MN in terms of A and B? To use the midline theorem, we have to create a triangle such that MN is a midline of that triangle. This can be done in many ways. Here's one of them. We connect A to N and extend all the way down, intersect with the segment CD at point E. Then we create a triangle ADE. M is the midpoint of AD. If we can show N is the midpoint of AE, then MN is a midline of the triangle. So the question is, can we prove N is the midpoint of AE? This can be done by showing a congruence of two triangles. NAB and NEC. Why these two triangles are congruent? You see, we have a midpoint. N is the midpoint. So NB equals NC. We have a side, and we also have two angles. This guy congruent with this guy, and also this angle is congruent to this angle because the parallel line and this is the alternative interior angle. Okay, so you see angle, side, angle, angle, side, angle. So these two triangles are congruent. Triangle NAB is congruent to triangle NEC. This tells us that N is the midpoint. That's NA equals NE. That means this guy equals this guy, which means MN is a midline of triangle ADE. So MN is 1/2 of DE. Okay. The question is, what is the DE? We know this part is B. Then what about this part? By congruence, this part is A. AB equals EC. So this part is B minus A. So we have B minus A, and we are done. So to conclude this video, let me explain that. So this technique, by introducing another line to create a midline, it's a typical technique. So let's consider another example. Consider a trapezoid, A, B, C, D. AB is parallel to CD, and the midpoint of AD is M, the midpoint of BC is N. We have the midline of the trapezoid, the top length A, the base B. Then we know MN is the average in B. How do we prove that? This is actually, so you see here, we connect AN all the way to E. We do similar thing. Connect AN and extend all the way down here, E. So then MN should be a midline of triangle ADE. Why? Because so we can prove the congruence of these two triangles. Midline angle and alternative interior angles, ASA, ASA, and then this part is A. You see this big triangle, the base has length A plus B. Then MN as a midline is half of A plus B. That's all I have today. Thank you for watching.